Medieval builders discovered that waiting years to dry timber the right way could triple its lifespan. Modern construction forgot why, and your house is paying the price. When you walk into any medieval cathedral still standing in Europe and look up, the timber roof beams above you, dark, massive, solid under the fingertips, are often older than your country. 600 years, 700 years. In some cases, dendrochronology can trace the tree rings back to forests felled in the 1200s or 1300s. The wood is still structurally sound. No punky softness, no catastrophic rot, no replacement needed. Now drive through a modern suburb and count the decks being rebuilt, the fence posts replaced, the siding torn off after 10 or 15 years. Treated lumber that was supposed to last a generation, failing in less time than a medieval apprenticeship. The gap is not about magic trees or lost forests. It's about one thing medieval builders understood at a visceral economic level. How you dry wood before you use it determines how long it will survive. In this video, you'll see exactly what that drying method was, why it worked so well, why we abandoned it, and how you can borrow pieces of it today, even if you're not building a cathedral. This is not about romantic nostalgia. It's about a system that routinely tripled or quadrupled the working lifespan of timber, backed by physics, fungal biology, and centuries of ruthless trial and error. Section 1. Why drying matters: the physics of rot. Before revealing the medieval method, it helps to understand what you're fighting. Wood rots because fungi digest it. Those fungi need three things simultaneously: moisture above roughly 20% by weight, oxygen and a food source, the cellulose, lignin, and sugars inside the wood cells. Take away any one element for long enough, and decay slows dramatically or stops entirely. Fresh-cut timber, sometimes called green wood, can hold 50% to over 100% moisture content by weight, depending on species and season. At those levels, the wood is heavy, dimensionally unstable, and extremely vulnerable. As it dries in place, inside a wall, under a roof, or buried in soil, it shrinks unevenly. Joints open, cracks form. Water enters those cracks and gets trapped. Fungi colonize the damp spots, and rot begins. Modern construction often amplifies this problem by sealing wet wood behind vapor barriers or non-breathable coatings before it has finished drying. The result is trapped moisture, perfect conditions for decay, and failure within a decade. Medieval builders, by contrast, treated drying as the first and most important stage of wood preservation, more important than any coating, tar, or oil you applied afterward. They built entire economic and construction rhythms around the idea that wood had to be stable, predictable, and bone-dry before it entered a building. The method they used was slow, labor-intensive, and required patience that modern timelines simply don't allow. But it worked. Section 2. The medieval drying method: air seasoning over years. The core of medieval timber preparation was long, slow air seasoning, sometimes called natural seasoning or open-air drying. Here's how it worked, step by step. Step 1. Winter felling. As covered in earlier discussions of medieval wood treatment, trees were ideally cut in winter when sap was down and internal moisture and sugar content were lower. This gave the timber a head start. Less food for fungi, less moisture to remove, and more predictable shrinkage during drying. Step 2. Conversion and initial stacking. Logs were stripped of bark, which can trap moisture and harbor insects, and converted into beams, planks, or rough-cut shapes close to their final dimensions. Leaving them as whole logs would slow drying dramatically because moisture in the center has to travel through many inches of dense wood to escape. Step 3. Stacking with airflow. The cut timber was then stacked horizontally in open-sided sheds or under simple roofs. Crucially, each layer was separated by thin sticks called stickers, placed perpendicular to the boards at regular intervals. These stickers created gaps that allowed air to circulate on all sides of every piece. The stack itself was raised off the ground on stones, bricks, or timber blocks to prevent ground moisture from wicking upward and to allow airflow beneath. The roof protected the wood from direct rain and sun, which could cause uneven drying, checking, and surface cracking. But the walls were open or minimal, ensuring steady airflow. Step 4. Waiting. Years, not weeks. The drying period was governed by a simple rule of thumb, already referenced in medieval and early modern sources, roughly 1 year of air drying per inch of thickness. That means a 1-inch plank needed a year, a 4-inch beam needed 4 years, an 8-inch structural timber might season for 6 to 8 years before use. During that time, moisture slowly migrated from the center of each piece to the surface, where it evaporated into the moving air. Internal stresses equalized. The wood shrank predictably, and any tendency to warp, cup, or twist expressed itself in the stack, not in a finished building. By the time the timber was ready, its moisture content had dropped to equilibrium with the local climate, usually somewhere between 12% and 18%, depending on region and season. At those levels, the wood was stable, strong, and far less hospitable to fungi. Section 3. Why this method tripled lifespan. The results of this patient approach were dramatic for several interconnected reasons. Reason 1. Dimensional stability. Wood that dries slowly and evenly before installation shrinks predictably and then stays put. Joints remain tight. Gaps don't open. When water does reach the wood during use, it can't penetrate deeply because there are fewer cracks and checks to exploit. Conversely, wood installed wet shrinks in place, pulling joints apart and creating pathways for moisture and fungi. Reason 2. Lower equilibrium moisture content. Air-dried timber that has spent years reaching equilibrium with outdoor air typically hovers around 15–18% moisture in temperate climates, below the 20% threshold where most decay fungi thrive. Even when it gets wet from rain, it dries back down quickly if properly designed and maintained. Green or partially dried wood, by contrast, may never drop below 20% in service, especially if trapped behind impermeable finishes. Reason 3. Reduced internal stresses. Rapid kiln drying, which became standard in the 20th century, uses heat and forced air to remove moisture in days or weeks instead of years. This speed creates steep moisture gradients between the surface and core of the wood, locking in internal stresses. Those stresses later express themselves as warping, checking, and cracking, especially when the wood encounters changing humidity in use. Medieval air drying, by contrast, was so slow that moisture gradients stayed shallow. The wood relaxed as it dried, arriving at its final state with minimal locked-in tension. Reason 4. Natural selection of durable pieces. Extended stacking also served as a filter. Pieces that warped badly, split deeply, or showed early signs of rot or insect damage during the seasoning years were simply discarded before ever reaching a building. Modern practice often tries to rescue every board with glue, fillers, or coatings. Medieval practice was more ruthless. If it didn't survive the stack, it didn't deserve a place in the structure. Reason 5. Chemical changes in the wood. Some historical sources and modern experiments suggest that very long air seasoning may also allow slow oxidation and chemical changes in wood extractives, tannins, resins, and other compounds that make the wood slightly more resistant to decay and insects. The evidence here is less direct than for moisture and stability, but it aligns with the observed fact that ancient timbers often seem harder and more durable than expected. Together, these factors didn't just add up, they multiplied. Stable, dry, stress-free wood, with tight joints and no hidden cracks, could easily last 3 to 5 times longer than wet, rushed, internally stressed timber installed fresh from the mill. Section 4. Water seasoning, the counterintuitive upgrade. For particularly important or vulnerable applications, some medieval and early modern builders took an even more extreme step. Water seasoning, also called pond seasonings, river seasoning. The process sounds paradoxical. Before air drying, logs or rough-cut timbers were deliberately submerged in ponds, rivers, or specially built water basins for months or even years. Why would soaking wood make it more durable? Several reasons. Reason 1. Leaching out nutrients. Water slowly dissolves and washes away water-soluble sugars, starches, and other nutrients that fungi and insects find attractive. Submerged wood becomes a less appetizing food source. Reason 2. Equalizing moisture and reducing stress. Immersion saturates the wood uniformly, eliminating internal moisture gradients. When the timber is later hauled out and air-dried, it dries more evenly from all surfaces, reducing the risk of deep checking or warping. Reason 3. Anaerobic protection during the soak. Submerged wood is not exposed to oxygen, so decay fungi, which need oxygen, cannot colonize it during the soak, even though it's saturated. Some of the oldest surviving wooden artifacts, including ancient piles under buildings like those in Venice, survived specifically because they stayed submerged and oxygen-starved for centuries. After the soak, the timber was pulled out, stacked with stickers, and air-dried in the usual way, but now with a cleaner internal chemistry and more predictable drying behavior. Water seasoning was more labor-intensive and required access to suitable water, so it wasn't universal. But for shipbuilding, bridge construction, and high-status buildings, it was a known upgrade that builders were willing to invest in. Section 5. The economics of patience. From a modern perspective, the most shocking part of medieval drying practice is the timeline. Waiting 4 to 8 years for timber to be ready sounds insane. But medieval construction operated on different economic assumptions. First, labor was often the limiting resource, not time. If seasoning timber required almost no active labor, just occasional restacking and inspection, it didn't compete with other urgent tasks. You could season hundreds of beams in the background while building other projects. Second, timber was expensive, and replacing rotten beams was even more expensive. A failed beam in a cathedral roof might require scaffolding, partial dismantling, and months of work. Preventing that failure by waiting a few extra years during initial preparation was an obvious trade. Third, buildings themselves were long-term investments. Cathedrals took decades or centuries to complete. Manor houses were expected to serve multiple generations. Barns, bridges, and mills were community infrastructure meant to last lifetimes. In that context, timber that might survive 200 years instead of 50 was worth the wait. Finally, the system created a rolling inventory. If you started seasoning timber every year, within a few years you always had dry timber ready to use. Apprentices seasoned wood their masters would install. Masters used wood seasoned by the previous generation. The delay was front-loaded, not ongoing. By the time industrial capitalism prioritized speed, standardization, and rapid turnover, this patient rhythm looked wasteful. But the cost was hidden: shorter building, lifespans, more frequent replacement cycles, and higher lifetime material consumption. Section 6. What happened? The rise of kiln drying. The medieval air seasoning method didn't disappear overnight. It persisted in traditional carpentry, shipbuilding, and rural construction well into the 19th and even early 20th centuries in some regions. But industrialization changed the game. Kiln drying, using heated chambers and controlled airflow to force moisture out of wood in days or weeks instead of years, became standard by the mid-20th century. From a business perspective, the advantages were undeniable. Faster turnover. Timber could be harvested, milled, dried, and sold in weeks. Predictable schedules. Construction projects no longer had to plan years ahead for timber supplies. Year-round production. Kilns worked in any weather, unlike open-air stacks vulnerable to rain and humidity swings. Insect and pathogen control. High heat. Killed bugs and spores during drying. Kiln drying, done correctly, can produce good results. Modern schedules carefully control temperature, humidity, and drying rate to minimize stress and checking. But economic pressure often pushes toward faster, cheaper schedules that prioritize throughput over quality. The result is timber that is technically dry by moisture meter standards, but may carry internal stresses, surface checks, and a tendency to move unpredictably when exposed to changing conditions. Worse, kiln-dried wood is often used immediately after drying, with no time to acclimate to the local climate where it will be installed. Medieval timber, by contrast, spent years acclimating naturally in the open air. Section 7. Modern consequences. Why your deck rots. The abandonment of long air seasoning shows up in failure patterns across modern construction. Decks and exterior structures are the most visible examples. Pressure-treated lumber, sold as weather-resistant, often arrives still damp from treatment. Builders install it immediately, seal it with stain or paint, and within a few years, the wood has checked, twisted, and begun to rot, especially at joints and end grain where water can penetrate. Interior framing lumber, though not exposed to weather, still suffers. Studs and joists cut from fast-grown plantation timber, kiln-dried on aggressive schedules, and installed wet can shrink significantly after walls are closed. Drywall cracks, doors stick, and gaps open at trim. Even expensive hardwood flooring can fail if boards weren't properly acclimated to the home's humidity before installation. Gaps, cupping, and buckling are common when kiln-dried wood installed in winter suddenly expands during humid summer months. The medieval solution to all of these problems was the same. Give wood time to reach equilibrium before you use it, and design buildings that let wood breathe and dry out when it does get wet. Section 8. What you can borrow today. Most people can't afford to wait 5 years before starting a project. But you can adopt pieces of the medieval drying philosophy and see real benefits. Strategy 1. Buy ahead and air season yourself. If you're planning a deck, shed, or outdoor project, buy lumber months or even a year in advance. Stack it at home with stickers, cover the top, and let it acclimate to your local climate. Even 6 months of additional air drying can significantly improve stability and reduce the moisture content of dried lumber that may still be holding 18–20% moisture from the kiln or treatment process. Strategy 2. Choose air-dried lumber when available. Some specialty mills and suppliers still offer air-dried lumber, especially for hardwoods used in furniture, flooring, and timber framing. It costs more and requires longer lead times, but the dimensional stability and longevity are noticeably better. Strategy 3. Acclimate interior wood before installation. For flooring, trim, and cabinetry, store the wood inside the space where it will be installed for at least 2 weeks, ideally a month, before cutting or fastening. Let it adjust to the temperature and humidity of that specific room. This simple step prevents most shrinkage and expansion problems. Strategy 4. Inspect and sort your lumber. Medieval builders threw away bad pieces during seasoning. You can do the same after purchase. Check for deep checks, twists, and excessive knots. Set aside the worst boards for non-structural uses or discard them. Using only the best pieces dramatically improves the longevity of the finished project. Strategy 5. Design for drying. Even with perfectly dried wood, moisture will find its way in during use. Design details that let wood dry out, raised foundations, generous roof overhangs, ventilated cavities, breathable finishes, are more important than any single preservative treatment. Section 9. The slow wood movement. In recent years, a small but growing number of builders, craftspeople, and timber framers have consciously returned to long air seasoning methods, often under labels like traditional carpentry, natural building, or slow wood. These practitioners argue that the quality difference is not subtle. Timber that has spent years drying naturally, machines more cleanly, with less tear-out and fuzzy grain, holds joinery more tightly and predictably, finishes more evenly, with deeper, richer color development, smells different, less acidic, more settled. Some timber framers maintain rolling stocks of oak, chestnut, and other hardwoods, deliberately cutting and stacking years before they need it. This requires capital and space, but the results, frames that will stand for centuries, justify the investment for clients who care about heirloom quality construction. For the curious, practical, and slightly nostalgic viewer, this movement offers a tangible connection to medieval methods, not as museum pieces, but as living, working techniques that still produce superior results when you're willing to pay the cost in time. Section 10. What the method really teaches. Strip away the specifics, the stickers, the years, the sheds, and the medieval drying method teaches one big idea. Durability is a function of patience and alignment with natural processes, not shortcuts and coatings. Wood wants to dry. It wants to reach equilibrium with its environment. It wants to move, shrink, and settle. Medieval builders didn't fight those tendencies. They designed around them. They gave wood time and space to do what it was going to do anyway. Before, not after, it became part of a structure. Modern construction often tries to force wood into unnatural states, trapped behind plastic, painted wet, nailed down while still moving. Then we're surprised when it fails. The triple lifespan that medieval drying methods produced wasn't magic. It was the result of working with the material instead of against it, and valuing longevity over speed. If you stand in a medieval hall where the roof beams are 600 years old, the most humbling thing is not the craftsmanship, though that is remarkable. It's the time horizon. The person who felled that tree never saw the finished building. The apprentice who stacked the timber to dry never cut the final joints. The carpenter who raised the frame expected their great-great-grandchildren to use it. That's the real method behind the method. Not just air and stickers and years, but a worldview that treated buildings as multi-generational infrastructure and timber as a material worthy of that responsibility. For anyone curious, practical, analytical, and just a bit nostalgic, the lesson isn't go back to the Middle Ages. It's this: if you want something to last 3 times longer, give it 3 times the preparation. Let it dry. Let it settle. Let it become what it's going to be before you ask it to hold weight. The medieval drying method worked because it respected time. Maybe that's the method we need to remember most.